Select the best set of reagents to accomplish the following transformation. So if we look at our starting material, we can see a ketone, and specifically it's a ketone that has an alkene that is conjugated to it. So we see an alkene between the alpha and beta carbons. We also call this an alpha beta unsaturated ketone. And this is important because these unsaturated systems have two electrophilic sites. So we want to pay attention to where we are reacting. And it looks like, if we look at our product, we've got that carbonyl intact, and we have formed a new bond at the beta position. A new carbon-carbon bond at the beta carbon. So to get your nucleophile to add to the beta carbon, it needs to be a weaker or less reactive nucleophile. Your strongly basic nucleophiles do direct addition at the carbonyl carbon. So we want a weaker base. And if we're forming a carbon-carbon bond, we're looking for an organometallic reagent. So what we're looking for then is a less reactive organometallic, so something like a dialkyl cuprate. And so we're adding 2 carbon atoms. That means it's an ethyl group. So we'd want, as our first step, we would want to have the diethyl cuprate. And in the second step, we want to add some sort of proton source, because initially you will have an enolate. And so that proton source would be something like water or an alcohol. So what we could imagine is taking place here, and this is not the exact mechanism of a cuprate, but we can kind of use this, right? It's a little bit more complex than what I'm about to draw. So you can imagine that that ethyl group is being transferred. You're pushing electrons in here and then up onto the oxygen. So not the actual mechanism. So just a disclaimer there, but it helps us to visualize things. And so we can imagine that we've transferred that one ethyl group. So there it is. We have formed the enolate. And so then in your second step, whatever your proton source is, and so let's take a look at our options to see what we're actually using. So we only have one with a copper lithium. So this is B. And so we're using as a proton source ethanol. So let me go ahead and draw ethanol as our proton source. And so it's here just to do this so that we can form the product that we are looking for, where we have added to the beta carbon and we still have a carbonyl. And of course, this pi bond is reacting, so that's why we no longer have the alkene.